Welcome to Ms. Parb's Flipped Classroom. For the next couple of weeks, we're going to be studying a particular kind of function, quadratic functions, and in this lesson, their functions and transformations. The objective is to be able to identify and graph quadratic functions and some vocabulary that you need. A quadratic function is a function with a degree of 2, the degree of 2 right here, where a is not equal to 0. The shape of the graph is a parabola, which is a U that opens up or down. Vertex form for the equation is f of x equals a times x minus h squared plus k, where hk is the vertex and a cannot be equal to 0. The axis of symmetry is a line that divides the parabola into two mirror images, and the equation for that line is x equals h, and this is the same h as in the x position of the vertex. Okay, our parent function is f of x equals x squared, and that's what we have graphed here because this is a positive x squared. So the parabola opens up, the vertex is at 0, 0. The vertex is a minimum because this is the lowest point on our parabola, and the axis of symmetry is the y-axis, or the line where x equals 0. When this is a negative x squared, then the parabola opens down. The axis of symmetry is still x equals 0. The vertex is still 0, 0, but now the vertex is a maximum instead of a minimum because it's the highest point on the graph instead of the lowest. Okay, so let's look at interpreting vertex form. If we have this equation for a quadratic in vertex form, y equals 3 times the quantity x minus 4 squared minus 2, we can line that up with the equation for vertex form, and we see that a is 3, h is 4 because the minus sign is part of the equation, and k is a negative 2 because this minus is not part of the equation. And here we wrote a is 3, h is 4, and k is negative 2. Since we know the vertex is the point hk, we know that the vertex would be 4, negative 2 because we know h and k. The axis of symmetry is the line x equals h, so for this graph it would be x equals 4. A is positive, so we know the vertex is a minimum because we know that the parabola will open up. And this is red, this is the minimum, and this is where it occurs. So we have a minimum of negative 2 at 4. So when x is 4, y is negative 2, and that's our minimum point. The domain, which are our x values, are all real numbers because we can put in any number on the x-axis that we want to. Our range is y greater than or equal to negative 2 because our lowest point is negative 2, and y is only going to get bigger. It will never be smaller. Okay, let's look at graphing quadratics. We can graph with translations. We can also use the vertex form to help us find the vertex and use that to graph it. So if we had x squared minus 5, that would be the same as x minus 0 squared minus 5. So we know that the vertex would be h, k, which would be 0, negative 5. And when we graph that, we have the vertex at 0, negative 5. We know it opens up because x squared is positive. And the other way to look at this is to take the parent function, and because of this minus 5, we know that we would just slide the parent down 5 places. So that's two different ways to look at how you could graph this. In this one, we have x minus 4 squared, which would be the same as x minus 4 squared plus 0. So the vertex would be 4, 0. And we could also look at this as the minus 4 is in the parentheses with the x, so we know that we would slide the parent graph 4 places to the right. Remember, it's the opposite of what you see in here. This last one has several transformations. You could look at it as the vertex is 1, 3. A is negative 2, so we know it's going to be stretched because a is greater, the absolute value of a is greater than 1. And it's going to flip down because this is a negative number. And if you replace x with 0, you can find that your y-intercept is the point 0, 1. So we slide this over 1 place to the right and go up 3, and then flip it over and put our point on our y-intercept and a corresponding point on the other side and draw the line. And just to remind you, the plus 3 here means you move up 3. This -1 means that you go 1 to the right. This -2, the negative means you're going to flip. The 2 means it's going to be a stretch, which means it's going to get longer and thinner. And you have a maximum of 3 at 1 because your vertex is the point 1, 3. Your axis of symmetry is x equals 1. Remember, it's always x equals this number. Your domain is all real numbers, and your range is y is less than or equal to 3, because this time our range will start here and go down to negative infinity. Okay, sometimes they'll give you information and ask you to write the equation in vertex form. This problem tells you that the vertex is 3, 7, and the point 9, 4 is a point on the graph, and write the equation for this quadratic in vertex form. Since this is the vertex, we know this is h and k. Since this is just a point, we know this is x and y. Here's the general equation for vertex form. We replace h with 3. We replace k with 7. And after we've done that, then we use this point and replace x and y with 9 and 4. So in place of y, we put 4. In place of x, we put 9. Now, if you look at this problem, the only variable that we have left to solve for is a. So we subtract 7 from both sides. Then we have a -3 equals 36a. Divide both sides by 36, and we find that a is a -112. So now we know a, we know h, and we know k, and we can plug those in to write the equation in vertex form. F of x is equal to a times x minus h squared plus k. So anytime you need to write the equation in quadratic form, if they give you this kind of information, replace h, k, x, and y, solve for a, and then go back and write your equation.